Unit 4.3 Measures of Dispersion. There are several ways to measure the variability of the data. Although the most common and the most important is the standard deviation, which provides an average distance for each element from the mean, several others are also important and are hence discussed here. A standard deviation is a statistical term that provides a good indication of volatility. It measures how widely values are dispersed from the average. Dispersion is the difference between the actual value and the average value.
Good morning, everyone. I am Tricia May M. Rivera, and I will discuss the range. Probably the simplest and easiest way to determine measure of dispersion is the range. The range is the difference of highest value and the lowest value in the dataset. There are two advantages of the range. It is easy to compute and it is easy to understand. On the other hand, it also has two disadvantages. It can be distorted by a single extreme value or outlier, and only two values are used in the calculation. So, range is a statistical measurement of dispersion, or how much a given data set is stretched out from smallest to largest. In a set of data, ang range ay ang pagkakaiba between highest values at lowest values within a set of numbers, while a large range means high variability. A small range means low variability in distribution. To find range, subtract the smallest number from the largest number in the set. In summary, the range is the difference between the highest and lowest values within a set of numbers. For example, the given data is the daily rates of a sample of 8 employees at GMS Incorporation are 550 pesos, 420 pesos, 560 pesos, 500 pesos, 700 pesos, 670 pesos, 860 pesos, and 480 pesos. So, paano nga ba natin mahanap o makukuha ang range? Meron tayong dalawang step. Step 1, i-determine natin kung paano makukuha ang highest value at lowest value sa dataset. So, as you can see, ito yung ating dataset. Meron tayong 550 pesos, 420 pesos, 560 pesos, 500 pesos, 700 pesos, 670 pesos, and 860 pesos, and 480 pesos. So, paano nga ba natin makukuha ang highest value? So, kung aling number dyan ang pinakamalaki, siya yung highest value natin. So, ang 860 ang pinakang malaking number natin, so siya ang highest value. Sunod naman natin i-determine ang lowest value sa dataset. So, ang pinakamababa sa dataset ay ang 420. Siya yung pinakamaliit na number. So, siya ang ilalagay natin sa lowest value. So, dahil tapos na tayo sa step 1, magpro-proceed na tayo sa step 2, which is yung solve for the range. So, magso-solve tayo para makuha yung range. Gagamit tayo ng subtraction para sa highest value and lowest value, which is ang highest value natin ay ang 860 pesos, tapos ang lowest value naman natin ay 420. So, 860 pesos minus 420 pesos equals 440. So, 440 ang ating range. So, the range in daily rate salary is 440.
Variance and standard deviation. One of the most widely used measure of dispersion is the standard deviation. The more spread apart the data, the higher the deviation. Standard deviation is calculated as the square root of variance. In finance, standard deviation is applied to the annual rate of return of an investment to measure the investment volatility. Standard deviation is also known as historical volatility and is used by investor as a gauge for the amount of expected volatility. Meaning to say po dito is ito sa pinakamalawak na ginagamit ng mga measure of dispersion. The more spread of the data, the higher deviation is. Also mean to this is the standard deviation is larger when the data values are more spread out from the mean, exhibiting more variation, and standard deviation ay kinakalkula bilang square root ng variance. Kung sa finance o pera, ang standard deviation ay inilalapat sa annual rate of return ng isang investment upang masukat ang volatility ng investment. Volatility in investment term that describe when a market or security experience period of unpredictable and sometimes sharp price movements. People often think about volatility only when price falls. However, volatility can also refer to sudden price rises. So yun, ibig sabihin ng volatility in term of investment. And standard deviation is also known as historical volatility and is used by investor as a gauge for the amount of expected volatility. So it is commonly used by investor to calculate the amount of expected volatility. Other infos that the standard deviation is the average amount of variability in your dataset. It tells you on average how far each value lies from the mean. A high standard deviation means that values are generally from the mean, while a low standard deviation indicates that values are clustered close to the mean. So yun yung meaning ng standard deviation.
Kung dun po sa simula, ang kinuha po dun ay range, dito naman po ang kukunin po natin ay yung variance and the standard deviation.
So, step 1, compute the mean of the dataset. Ilalagay lang natin yung mga mean na nakalagay dun sa problem. Ang problem natin is the daily rates of a sample of 8 employees at GMS Inc. are 550 pesos, 420 pesos, 560 pesos, 500 pesos, 700 pesos, 670 pesos, 860 pesos, and 480 pesos. Ilalagay lang natin dyan. Tapos nakalagay sa solution natin is minus n. S over n. Tapos, so, ang mean natin ay 8, kaya ang ilalagay din natin dun sa baba ay 8. Tapos, pagpa-plusin lang natin, dahil nga nakalagay sa step 1 is, i-compute yung mean of the dataset. Pagpa-plusin lang natin tong 8 na mean, 500 hanggang dito sa kabila, is equals to 4,740 over 8. 8 dahil 8 yung mean. So, 4,740 divide 8 is equals to 592.5.
Tapos, step 2, subtract the mean from each of the value in the dataset. So, itong mga mean na to, itong mga mean dito, ilalagay lang dito at saka yung total. Tapos, dito sa kabila, ang mangyayari, 550 ima-minus dito sa total na 592.5. So, ito ay magiging 550 minus 592.5 is equal to 442.5. Tapos, 420 minus 592.5 is negative 172.5. Tapos, ito namang isa, 560 minus 592.5 is equal to negative 32.5 and so on. Ganun lang din ang gagawin dito sa kabila. Ganun lang din ang gagawin dyan dito sa pababa. Dyan sa lahat. Pare-pareho lang yan. So, from step 3, square the x minus x, then get the sum. So, ito, dito po natin siya ilalagay. Gawin po ay square. Ang bawah po, 42.5 squared. Diyan gagawin.
Ang example po ay negative 42.5 squared. Ayan po ay magiging 1,806.20 point. Tapos, ganun lang din po ang gagawin sa iba. Equals 6.24 tapos ang squared equals 71 6.25 tapos negative 0.12 squared equals 12 6.25. So, ang magiging x squared. Ayan po magiging total po nila ay pag minus 1, 4, 2, 4, 9, 3. Step 4. Solve for variance and standard deviation. We can also obtain the standard deviation by simply extracting the square root of the variance. Aring 142,950 over 8 minus 1. Aring are ay andon sa last step. Yung total doon is equal to 20,421.43 and square root of 142,950 over 8 minus 1 square root of 20,421.43 is equal 142.90. So, ang variance po natin is 20,421.43 and ang standard deviation naman po natin ay 142.90 pesos.
So for the example 3, the problem is the monthly incomes of the 5 researcher directors of Recoleto schools are 55,000, 59,500, 62,500, 57,000, and 61,000. Find the variance and the standard deviation. Find the variance and standard deviation. So for this variance, how to get the variance and standard deviation? Step 1 is to compute the mean of the dataset, which means yung mga given number na nasa example 3 is the 55,000, 59,500, 62,500, 57,000, and 61,000 over the population. So, ang total lahat niyan pag pinag-add natin is 295,000 over 5. So, 295,000 divided by 5 is equals to 59,000. So, for the step 2 is, sabi dito is subtract the population mean from each of the value in the dataset. So, yung population mean na nakuha natin kanina is 59,000 dito sa step 1. And then, we need to subtract the population mean from each of the value in the dataset. So, itong mga value na nakuha natin is, we need to subtract to the population mean, which is the 59,000. So, first is 55,000 minus 59,000 is negative 4,000. And then 59,500 minus 59,000 is equals to 500. 62,500 minus 59,000 is 3,500. Then, sunod-sunod lang yung procedure niyan na isubtract lang natin lahat ng value na nasa dataset na ito is subtract lang natin dito sa population mean. So, ang makukuha natin is ito naman. So, now for this step 3 is get the sum of x value, population mean, then get the sum. So, itong nasa second table na to is ito yung gagamitin natin to get the sum of all this. So, yon yung magiging illustration ko dito is ito siya. So, try natin siyang i-solve. Negative 4,000 squared to 2 equals to 16 million. So, ito siya. So, kinumpute ko na siya kanina. So, yan yung magiging sum nila na makukuha natin. So, sunod-sunod lang yung procedure na yan. So, next naman is 500 squared to 2 equals to 250,000. So, nandito siya. Then, pagkatapos natin makuha lahat yan is ito-total natin siya. Which is, ang kalalabasan niya is 36,500,000. So, for the last step, day step 4, kung paano natin makuha yung variance and standard deviation is, sabi dito is solve for the population variance and population standard deviation. So, variance equals value population mean squared over population. So, ito siya, kung yung example 3 is, ito yung nakuha natin na tinotal natin dito sa third table. Which is ito siya, 36,500,000 over population 5. Then equals is 730,000. So, paano natin nakuha yun?
Likely to be encountered
lagay
are
natin
deciles, which
36
split data into 10
million
parts, and percentiles, which split the data into 100 parts, also called
divided by
centiles.
5.
Values
Divide natin
such
siya sa 5,
as
which is
quartiles
yung
can also
population.
be expressed
Then, ang
as
magiging sagot niya is
centiles. Values such as
730,000.
quartiles
So, yun
can
yung
also be expressed as
population variance
percentiles. For
natin.
example, the
So,
lowest
yun, nakuha na
quartile
natin
is
yung
also the 20th
population
percentile,
variance, which
and
is
the median is the
730,000.
50th
So,
percentile or the
sa
5th
population standard deviation
decile.
naman natin yung kukuhanin natin. So, gamitin natin yung formula na standard deviation, square root, value population mean over n, which is the population. So, ito yung magiging kalalabasan niya. Square root of 730,000. And then, try natin siyang i-solve. So, square root of 730,000 is equals to 2,701.85. So, hence the population variance is 730,000. And then, for population standard deviation is 2,701.85. So, ito yung step kung paano kuhanin yung variance and standard deviation. Then, sana nagets nyo yung illustration ko kung paano siya isolve and kuhanin. Find the variance and standard deviation. So, for this variance, how to get the variance and standard deviation? Step 1 is to compute the mean of the dataset, which means yung mga given number na nasa example 3 is the 55,000, 59,500, 62,500, 57,000, and 61,000 over the population. So, ang total lahat niyan pag pinag-add natin is 295,000 over 5. So, 295,000 divided by 5 is equals to 59,000. So, for this step 2 is, sabi dito is subtract the population mean from each of the value in the dataset. So, yung population mean na nakuha natin kanina is 59,000 dito sa step 1. And then, we need to subtract the population mean from each of the value in the dataset. So, itong mga value na nakuha natin is we need to subtract to the population mean, which is the 59,000. So, first is 55,000 minus 59,000 is negative 4,000. And then 59,500 minus 59,000 is equals to 500. 62,500 minus 59,000 is 3,500. Then, sunod-sunod lang yung procedure niyan na isubtract lang natin lahat ng value na nasa dataset na ito is subtract lang natin dito sa population mean. So, ang makukuha natin is ito naman. So, now for this step 3 is get the sum of x value population mean, then get the sum. So, itong nasa second table na to is ito yung gagamitin natin to get the sum of all this. So, yon yung magiging illustration ko dito is ito siya. So, try natin siyang isolve. Negative 4,000 squared to 2 equals to 16 million. So, ito siya. So, na-compute. So, kinompute ko na siya kanina. So, yan yung magiging sum nila na makukuha natin. So, sunod-sunod lang yung procedure na yan. So, next naman is 500 squared to 2 equals to 250,000. So, nandito siya. Then, pagkatapos natin makuha lahat yan is ito total natin siya. Which is, ang kalalabasan niya is 36,500,000. So, for the last step, day step 4, kung paano natin makuha yung variance and standard deviation is, sabi dito is solve for the population variance and population standard deviation. So, variance equals value population mean squared over population. So, ito siya, kung yung example 3 is, ito yung nakuha natin total natin dito sa third table. Which is ito siya, 36,500,000 over population 5. Then equals is 730,000. So, paano natin nakuha yun? So, lagay natin 36,500,000 divided by 5. Divide natin siya sa 5, which is yung population. Then, ang magiging sagot niya is 730,000. So, yun yung population variance natin. So, yun, nakuha na natin yung population variance, which is 730,000. So, sa population standard deviation naman natin yung kukuhanin natin. So, gamitin natin yung formula na standard deviation, square root, value population mean over n, which is the population. So, ito yung magiging kalalabasan niya. Square root of 730,000. And then, try natin siyang isolve. So, square root of 730,000 is equals to 2,701.85. So, hence, the population variance is 730,000. And then, for population standard deviation is 2,701.85. So, ito yung step kung paano kuhanin yung variance and standard deviation. Then, sana nagets nyo yung illustration ko kung paano siya isolve and kuhanin.
Unit 4.4 Measures of Relative Position. When presenting or analyzing dataset, it is sometimes helpful to group subjects into several equal groups. For example, to create 4 equal groups, we need the values that split the data such that 25% of the observations are in each group. The cut-off points are called quartiles, and there are 3 of them, the middle one also being called the median. The general term for such cut-off points is quantiles. The other values likely to be encountered are deciles, which split data into 10 parts, and percentiles, which split the data into 100 parts, also called centiles. Values such as quartiles can also be expressed as percentiles. For example, the lowest quartile is also the 25th percentile, and the median is the 50th percentile of the 5th decile. Example 1. Find the first, second, and third quartiles of the ages of 9 middle management employees of a certain company. The ages are 53, 45, 59, 48, 54, 46, 51, 58, and 55.
Nasimulan ko po na po siya. Kaya 2.25 po yung sagot is dito muna, quartile 1, 1. 8 plus 1 equals 9 times 1. Kaya naging 9 dito. Tapos over 4, ginaya lang dito. Tapos decimal 9 over 4 is 2.25. Kaya kailangan niya maging integers kasi nasa pagitan siya ng 18 at 24. So gagamit tayo ng interpolation. That is, ganito po siya. Quartiles 1, second plus 0.25 tapos third minus second. Ang quartile ones po eh. Ang second po natin is 18, kaya dito po siya 18 plus 0.25, 0.25. Ang third natin is 24 minus, ang second is 18. So 24 minus 18 times 0.25 plus 18 equals quartiles 1
Example,
is
construct a box plot for the
19.5.
data set of ages of middle
Ito yung
management
quartile
employees of
natin.
a certain
Ang
company.
quartile 2
The
naman
ages
po,
are
start
53,
na po tayo sa
45,
quartile 2.
59,
Quartile 2 na
48,
po yung
54,
hinahanap niya,
46,
kaya
51, 58, and
ang
55.
1 po dito is magiging 2 na. Quartile 2 plus 1 4 quartile 2 8 plus 1 is 9 times 2 18 per 4 tapos quartile 2 equals to decimal 18 over 4 is 4.5 fifth. Kailangan niya rin maging integers kasi nasa pagitan siya ng 33 and 47. So, gagamit din ulit tayo ng interpolation, that is quartile 2 equals fourth plus 0.5 tapos fifth minus fourth. Ang quartile 2 equals, ang fourth po natin is 33, kaya 33 po yung dito, plus 0.5, and ang from fifth naman po natin is 47 minus pang fourth is 33. That's why ang quartile 2 natin is 47 minus 33 times 0.5 plus 33 equals 40. Ito na po yung quartile 2 natin. So, ang hahanapin naman po natin now is quartile 3. Quartiles 3. Quartile 3, same as ng ano pa rin po, kaso mababago na rin ulit siya ng yung quartile 3. Tapos magiging 3 na din yung nasa loob niya kasi quartile 3 na po yung hinahanap natin. Over 4. So, quartile 3 open. 8 plus 1 is 9 times 3 equals 27 over 4. Tapos, decimal 27 over 4 equals quartile 3 is 6.75. 75th. Hindi ulit siya pwede kasi nasa pagitan siya ng 61 at 72. Kaya, gagawin natin is, gamit pa rin tayo ng interpolation. Quartile 3 equals 6 plus 0.5, 0.75. So, ang pang-anim natin is 59. So 59 ito 59 plus 0.75 tapos ang pang 7 natin is 61 minus 59 tapos yan close 61 minus 59 times 0.75 plus 59 ang quartile 3 natin is 60.5.
C-score. C-score is used to know the position of one observation relative to others in a set of data. We apply C-score. Let's say we want to know a C-score of student of 42 compared to the scores of the other students in the class based from a quiz on a total of 50 points. The mean and the standard deviation of the scores can be used to compute a C-score, which will measure the relative standing of a measurement in a dataset. A C-score measures the distance between an observation and the mean, measured in units of standard deviation. The following formula show how to compute the C-score for a data value X in a population and in a sample. For population, the formula is Z is equal to value minus mean over standard deviation. For sample, Z is equal to value minus mean over standard deviation.
So for our example number 1, the monthly expenditures of a large group of households are normally distributed with a mean of 48,700 pesos and a standard deviation of 10,400 pesos. What is the Z value of monthly expenditures of 59,400 and 38,300 pesos? So for us to find out, we need to find a solution. So, let the mean, which is yung 48,700, and the standard deviation, which is yung 10,400. So, ang x natin, ang hinahanapan natin ng value ay yung 59,400 and 38,300. So, sila yung naging x natin. So, first, ito munang 59,400. Ang ginamit natin na formula to find out what is the Z value is yung formula for the population since nabanggit sa problem yung word na large group. So, copy lang yung formula, then substitute x 59,400 and the mean, which is yung 48,700 divided by the standard deviation 10,400. So, ang naging sagot niya ay 1. And the next one is the 38,300. Ganun lang din, same procedure dun sa nauna. Copy lang yung formula for population, then substitute
So, eto yung x, dito natin siya nakuha sa hinahanapan natin ng z-value na 38,300. Copy lang natin. Minus the mean, which is yung eto, 48,700. Divided by the standard deviation, 10,400, which is ang magiging sagot ay -1. Saan nakuha yung 10,400? Nandito na din siya sa problem, which is ito, a standard deviation of 10,400. So, yun. So far, our conclusion, the z-score of 1 indicates that a monthly expenditure of 59,400 pesos for household is one standard deviation above the mean. And a z-score of -1 shows that a 38,000 monthly expenditures is one standard deviation below the mean. And both of the household monthly expenditures are the same distance from the mean. And note that the z-scores can have negative as well as positive values.
The given mean is 650. The given standard deviation is 40. The given value is 575. The formula we're going to use is C is equal to value minus mean over standard deviation. First, we're going to subtract the value 575 to mean 650. 575 minus 650 is equal to -75. Next, we're going to divide the -75 to standard deviation 40. -75 divided by 40 is equal to -1.875. Therefore, the value of 575 has a z-score of -1.875. The given mean is 5.64. The given standard deviation is 0.97. The given z-score is 1.53. The formula we're going to use is value is equal to mean plus zs or z-score times standard deviation. First, we need to multiply the z-score to standard deviation. 1.53 times 0.97 is equal to 1.4841. And next, we need to add the mean and the 1.4841, and 5.64 plus 1.4841 is 7.1241. Therefore, the item had an assembly time of 7.12 minutes.
So for our example number 4, the salary of junior executives in a large corporation in Ortigas area in normally distributed with a standard deviation of 15,600 pesos, cut back is spending at which time those who earn less than 85,000 pesos will be discharged if such a cut represents a z-score of -1.28 of the junior executives. What is the mean salary of the group of junior executives? substituting the given values to determine the mean value, we get the sample data where we were going to use the formula x minus the mean over the standard deviation. So, magiging equal siya sa mean is equal to x minus our given z-score. So, by using the formula, mean is equal to x minus the z-score is equal to 85,000 minus negative 1.28 times 15,600 is equal to 85,000 plus 19,968 is equal to 104,968. Thus, the mean salary of junior executive is 104,968 pesos.
Maaaring magmukhang komplikado ang box at whisker plot, pero kailangan lang nitong maunawaan kung ano ang tinitingnan at nire-represent ng box at whisker plot. Ang box and whisker plot are way to display data and the spread of that data. They give us a visual. Ipapakita ko sa inyong isang example ng box and whisker plot. Titingnan natin ang mga taon ng teaching experience. May 10 teachers na nag-survey at ito ang result. 3, 3, 7, 8, 8, 10, 11, 12, 15, and 18. Again, this is years of teaching experience. Ang mga data, ito po yung mga data. Ang mga data ay naka-order from least to greatest number. At ang box and whisker plot ay ito po. Ngayon, when it comes to box and whisker plot, there are 5 key parts. Sila ang magpapakita ng 5 numbers of summary set. Box and whisker plot display the minimum, the first quartile, the median, the third quartile, and the maximum. Ang minimum is a lowest number and the maximum is the highest number. Magsisimula tayo na makita ang minimum and maximum. Ang minimum numbers of years of teaching experience is 3. Minimum. And the maximum is 18. Why? Dahil ang 3 is the least number, kaya ito po ay naging minimum number. And 18 is the highest number, kaya ito po ay naging maximum number. Kaya ang minimum or lowest number is 3. Lalagay natin siya dito. And the maximum number or highest number is 18 years. The minimum is 3 years and the maximum is 18 years. The minimum and maximum are just the smallest and largest number in value within the dataset. So as far as the box and whisker plot, we have the minimum right here. Right here. and the maximum right here. So let's label this minimum and maximum. So the whiskers that extend out from the rectangle, we're actually going to move to the middle. And we're going to take a look at this line. The line right here inside the rectangle. That line represents the median. That is median. The median is the middle point of the data, the halfway point, or the 50th percentile. The median is also referred to as the second quartile. Ang median ay nag-refer as the second quartile. Now, since we have 10 numbers, 3, 3, 7, 8, 8, 10, 11, 12, 15, and 18, within the dataset, the halfway point is going to be in between 8 and 10. Ang halfway point or ang hati sa gitna ay between 8 and 10. Ito po ang median. Hinati nito ang data sa set. We have 5 numbers to the left, 1, 2, 3, 4, 5, and 5 numbers to the right, 1, 2, 3, 4, 5. Now, we are directly in between 8 and 10. So, we take the average of those 2 numbers. So, to find the median, mag-take po tayo ng average para po mahanap yung median. So, para mahanap po yung median, ang gagawin po natin ay gagamit po tayo ng addition and division. So, ang gagawin po natin is to find the median. Gawin natin ay 8 plus 10 divided by 2. So, 8 plus 10 equal 18. 18 divided by 2 equal 9. Now, 8 plus 10 equal 18 divided by 2 equal is 9. So, the median is 9. So, ang median po natin is 9. Median po natin is 9. Tandaan, sa tuwing mayroong dalawang number ay kailangan mong hanapin ang average para magawa ito. So again, the line inside the rectangle is the median. So that's the halfway point within our data. Now we need to take a look at the first quartile. So ilalagay po muna natin yung median. So ang median po natin is 9. Ang first quartile is also known as the lower quartile. And then the third quartile is also known as the upper quartile. let's take a look at the first quartile. Kailangan nating tingnan ang nasa ibaba ng data. Ngayon, ang first quartile ay magiging median o halfway point sa loob ng ibabang kalahati ng data. So titingnan natin ang kalahating ibaba ng data. And sabi doon, ang first quartile daw ay magiging median o halfway point sa loob daw ng ibabang kalahati ng data. So this is going to be the median of the bottom half of the data. That means that going to be the first quartile, that's the 1/4 mark within our data. So the 25% mark or 25th percentile. So the first quartile is 7. Ang first quartile po natin is 7 because siya po ay nasa halfway point ng kalahating ibaba ng data. That's represented by this part of the rectangle. So, this is the first quartile or lower quartile. Again, it's 7. Dito po sa part na to ay ang first quartile. Now, we need to find the third quartile. Meron na po tayong first quartile at ito po ay 7. So, ilalagay po natin siya dyan. And then, let's take a look at the upper half of our data. Sa kabilang half naman po ng data, we need to find the median. Kagaya po nung una, sa first quartile, hahanapin din po natin yung median sa kalahating upper half data. We need to find the median. So, the midpoint of that upper half, that's going to be right here. So, 12. 12 po ang 12 po ang median sa upper half data. So, siya po ay magiging ang 12 po ay ang third quartile. The third quartile, that's 3/4 mark within our data. So, the 75% mark or 75th percentile. So, the third quartile is 12. And that is going to be this part of the rectangle. So, dito po yung third quartile. Those are the 5 parts. Of a box and whisker plot. Ito po ay minimum or lowest number, first quartile or lower quartile, median, third quartile or upper quartile, and maximum or highest number. We have the minimum, which was 3 years of teaching experience. So the minimum was right here. Then we have the first quartile, which was 7. So right here. Then we have the third quartile, which was 12. So right here. And then we have the maximum, which was 18 years. And the median, which was 9. So right here. Box and whisker plots use quartiles. So the data is split into 4 parts. So 4. Nahati po siya sa 4 na parts. Now the box within the box and whisker plot represent the interquartile range. We have about 25%, 25%, and then we have the 25% right here, and then 25% right here, and 25% right here. Now the box within the box and whisker plot represent the interquartile range. So the middle 50% of the data, and then a whisker extend to the minimum, that's going to be the bottom 25% of the data, and the other whisker extend to the maximum, that's going to be the upper 25% of the data. So one final recap here, meron po ako dito na isa pa pong copy, and then ipapakita ko po sa inyo yung pinaka overview po ng box and whisker plot. So one final recap here, we have the minimum, which is 3. And we have the first quartile, which is represented is 7. Then we have the median, which is represented right here, is 9. Then the third quartile is represented right here, that is 12. And then lastly, we have the maximum, which is 18 and represented right here. So there you have it. There is an overview of how to read and interpret and basically understand what you're looking at when it comes to box and whisker plot. Thank you.
So we have here a step-by-step solution. Step 1 is determine the first quartile, the median, and third quartile of the given dataset. Recall that first quartile is equal to 47, median is equal to 53, and the third quartile is 56.5. Note, median is the middle point of the data, the halfway point, or the 50% of the given ages. The first quartile is the other half of the numbers in the left side of the median, so this would be the number between 46 and 48. The third quartile is the other half of the number in the right side of the median, so this would be the number between 55 and 58. Step 2. Locate the lowest value, the first quartile, the median, the third quartile, and the highest value on the scale. So here is the position of the lowest value, the first quartile, the second quartile, and the highest value on the scale. Step 3. Draw a box around first quartile and third quartile. Draw a vertical line through the median and connect the upper and the lower values. So this is our lowest value. Then our highest value is 59. And this is our median, 54. Our first quartile is 47. And lastly, our third quartile is 56.5. Therefore, since the median falls to the right of the center of the box, the dataset of distribution is negatively skewed.